Alright, let's give it another crack. I accidentally revealed some secrets of the void in the last attempt, so I had to restart this video. This is Math from the Void, Calculus Prep Part 8. And here we go. Math coming at you out of nowhere. We're going to be talking about transformations today, and we're going to graph some transformations. So put your transformations hats on. Get ready to talk about this function, the square root function. And we're just going to observe some simple transformations. So the function on the left, here the square root function, is f of x equals the square root of x minus 2. And it has been transformed somehow to turn into this graph that's on the right. You can see first impressions is that this has clearly been like flipped. It's been reflected. So it's going that way instead. Right, see how it's going that way now. Let's see. The special location here, the starting point, has been moved, so we're definitely going to have to factor that in. In fact, it looks like it's just been completely flipped to the other side, so it goes from 2 to negative 2. And then the y value is also changed. We've gone up by 3 spaces. So let's write down some of those transformations. We have a shift up by 3. And we're also reflecting, which way does this reflect? This reflects across the y-axis. Now when we reflect across the y-axis, the way that we write the equation is we make the x negative. Okay, so let's go ahead and do that. That means we're going to have f of negative x and then plus 3. So describing the transformations, we've done that. And we're also going to write the equation for the new shape. So we want f of negative x and plus 3. We're basically just going to replace the x in the original function with a negative x. This will be negative x minus 2. And then outside of the square root, we have plus 3. We could also write this with the negative factored out. It might be preferable to write it like that. There we go. That's the equation of this transformed function. And that covers part A. Part B is going to keep talking about this. So you can see they've used this notation again. Get familiar with transformation. I told you to put your transformation hats on. So if you're not wearing your transformation hat, pause the video, go get your transformation hat, put it on, make sure it's on good, look in the mirror, stuff like that. And then you can get back to this. So let's talk about what transformations are going on here. Let's see. It looks like the text box is not functioning very well. So I'm going to have to write these out by hand. What does this tell us? This tells us a shift to the right by 2. And this one tells us that we're going to go down by 1. Observe the negative. What does that tell us? It tells us bad vibes. No, it tells us that we're going to flip across the x-axis. So in other words, it's going to flip it downwards. We're going to reflect anything on the bottom to the top and anything to the top, or anything that's on the top to the bottom. And I think it would be easiest if we're able to actually write the function. So let's build the function from the inside out. This is a great technique for writing functions. So remind ourselves what the original function is. There's the original function. So then what's f of x minus 2? Well, that's going to be square root of x minus 2 and then minus 2. See what I've done? Is I've replaced the variable with x minus 2. So that's just going to turn into the square root of x minus 4. Okay, we're still building this function. Now let's put a negative on it. So that means negative f of x minus 2. is simply going to be negative square root of x minus 4. Oops. There we go. And then lastly, if we want to do that minus 1 to shift everything down by 1, that's going to look like this. Negative square root x minus 4 minus 1. So from the normal square root parent function, this is going to be shifted to the right by 4. But since the original function was already shifted to the right by 2, that matches with our transformation of shifting to the right by 2. Because if we already started here shifted by 2, if we start at 4 now, that's like shifting f of x. It's like shifting this one by 2. The original parent function would look something like that. So from the parent function, this would be a shift of 4. That's why we have x minus 4. But from the function we started with, which was x minus 2, to x minus 4, we've only shifted by 2. I hope that makes sense. If not, just keep thinking about it a little harder. Okay, so let's graph this. This is negative 4, so that means it moves to the right 4. Oh, and it's down 1 as well. So our starting point is here. Oh, whoops. Actually, if we shift 4, and then we flip it downwards, it's going to go a little something like this. But we have a shift down by 1, so we're going to take all of that. And we're going to shift it down 1, just like that. There we go. Oop, our arrow. All right, so that's the graph. Not too bad, right? Very easy to do, I think. Very doable. If we want the original function, there's the exact function, exact equation for that graph. Okay, speaking of graphs that we should know how to do, let's move on to this quadratic function. Now I want you to notice that this is a different quadratic function. This is not a quadratic function of the type y equals x squared, or ax squared plus bx plus c. This is a little bit different. This is different. You notice the x and the y are switched. So instead of an up and down parabola, this is going to be, great, my text box doesn't work. This is going to be like a horizontal, or like a left and right parabola. So it's either going to open to the left if it's negative, or it's going to open to the right if it's positive. And it looks like it's positive. It's in the exact same format as this quadratic equation, but it just has y's instead of x's, and it has an x here instead of a y. So the process for finding the vertex is really pretty much the same thing as the process for finding the vertex with a typical quadratic function that we're used to looking at. The only difference is that when we're looking for the axis of symmetry, which is step 1, instead of saying x equals negative b over 2a, I'm going to say y equals negative b over 2a. Really similar to the first step of finding the vertex of a regular quadratic equation. But since we switched the x and y's, we're going to switch the x and y's here as well. So if we analyze this with a 1 and a negative 4 and a positive 3, this is going to give us 4 over 2. Well, it's negative 4 over 2. Which is 4 over 2, which is just 2. Now that's the y value, okay? So very careful about that. That's the y value. So that means that the symmetry, the middle of the parabola is somewhere on that line. Now step 2 is to find the vertex location. We have to find the x value. And so we're just going to plug this in. we have 2 squared minus 4 times 2 plus 3. So here we go, 4 minus 8 plus 3. That gives us negative 1, and that tells us the x location of the vertex. So right there. Okay, and we know that it opens to the right. It's a positive. So it's going to do something kind of like that. But I'm not satisfied with this picture. We need more specific information. I found the vertex, whoop-de-doo. And I happen to know from experience that I have a point right here, one up, and a point right here, one down. But if I didn't know that, and I still wanted to find the x and y intercepts, I would be able to find the x and y intercepts because we know how to find x and y intercepts. We've done this a couple of times. For the x-intercept, you're going to make y equal to 0. And for the y-intercept, you're going to make x equal to 0. Now, normally, the y-intercept is the easiest thing to do in the world, but that's because normally we have a function of x, and it's really easy to plug in x equals 0 to a function of x. This time, we have a function of y, and so it's going to be easiest to find the x-intercepts, or x-intercept, I should say. There's only one of them, and that's because it's easy to plug in y equals 0 when we have a function of y. So let's find the x-intercept first. If we make y equals 0, x just equals 3. There we go. And because this line of symmetry, we're going to get a point exactly up here. Kind of nice that we get that one for free. Now when we set when we set x equal to 0 to find the y-intercepts, we have a quadratic situation, but it's a quadratic equation in y rather than a quadratic equation in x. This one happens to factor really easily into y minus 3 times y minus 1. And using the zero product property, that means y equals 1 and y equals 3 are both solutions. And so now I'm a little bit more satisfied with the shape of this graph. Okay, that was some good, clean family fun from the void, math hitting you out of nowhere. Keep working hard. We're going to continue with this calc prep assignment, and I promise by the time you're done with this, if you're not prepared for calculus, that means you didn't take this seriously enough. See you next time.